Hi, welcome back to our channel. In this video, we are going to find out the eigenvalues by using the givens method. So in the previous video, we found the eigenvalues using the givens method for the matrix which is not tridiagonal matrix. So here the matrix which is given is already tridiagonal matrix. How? You can observe 0 and 0, minus 1, minus 1, minus 1, minus 1. So here this is the format of tridiagonal matrix. So for this we should calculate the eigenvalues, okay, and also in this eigenvectors we should find. So first you should write this standard matrix b1 c1 c1 b2 c2 c2 b3, and these are 0. F0 is 1, f1 is lambda minus b1, b1 is 2 here, so lambda minus 2, f2 lambda minus b2, f1 minus c1 square, f0. So lambda minus b2 value is here 2, so we should write lambda minus 2, f1 is here lambda minus 2, c1 square means, so here c1 minus 1 square, f0 is 1. So we will get f2 from this. Similarly f3 lambda minus b3, f2 minus c2 square, f1. So lambda minus b3 value is, you can observe here, b3 is 2, so lambda minus 2. Then lambda minus 2 square. Why? Because f2. What is the value of f2? f2 is this much. So lambda minus 2, lambda minus 2, lambda minus 2 square minus 1 square is plus 1. So here it is minus as it is, so it is plus 1. Minus c2 square. What is c2? Minus 1 square. And f1. What is f1? f1 is lambda minus 2. So if you solve this, right, by separating this lambda cube, lambda square and lambda, you are going to get f3 like this. So take the calculator and just put in this equation format, so you will get these three values, lambda 1, lambda 2, lambda 3. These are the eigenvalues. If it is directly given the tridiagonal form, it's very easy to calculate this lambda values, that is called as the eigenvalues. Suppose I want to find this eigenvectors. So how to find the eigenvectors? I should find the eigenvector when the eigenvalue is this, eigenvalue is this, and eigenvalue is this. So here how to calculate is a determinant of a minus lambda I is equals to 0. So eigenvector when lambda is equal to, I will take this first one, a minus lambda I into x equals to 0. What is a? A is here the given matrix. Take that a, lambda I means we can write like this, into x is equals to 0. So 2 minus lambda, what is the value of lambda here? 2 minus 0.5, so that is this. So this you will get if you go for this operation. So here you can carefully observe, it is 1.413 into x1 minus 1 into x2 plus 0 into x3 equals to 0. So that is what we can write here. Second row and third row. In the third row I will be having 0, first row I will be having 0. So I am taking first row and third row and I will write these two equations. Okay. So first equation 1.413 x1 minus x2 equal to 0. So 1.413 x1, push this x2 here. So I will get x2. So here make it x1 divided by x2 is equals to 1 divided by this 1.413. So x1 value is 1, x2 value is 1.413. What is x3? How I will get x3? If I go for this equation, that is this equation. So minus x2 equal to this much. So x3 is equals to x2. So if you do this, x3 by x2 equal to 1 divided by 1.41. So 1 is the x3 value. So this is the eigenvector which is corresponding to the eigenvalue, this one. Okay. So this similarly we can find the eigenvector corresponding to these two values. Okay, you can find that based on these guidelines. Okay, we'll see in the next video about the next update. This is the problem when the matrix is given directly as a tridiagonal matrix. If it is not given as a tridiagonal matrix, I have solved in the previous video. You can go and check that video. That is this form, the matrix which is not tridiagonal matrix. This type of problem I have solved. Thank you.